We're doing section 3.5, example 3.4. We're now on page 118, but actually they give you a little verbiage at the bottom of page 117 that I want to go over. If you remember that on example 1 and 2, they were talking about dollar amounts. They were increasing or decreasing a loaf of bread. And on example 2, they were talking about the increase or decrease of votes. But we are now going to talk about, well, what if the increase or decrease has to do with a percent, not a dollar amount or not a number of votes or a number of items, but a percent. So let's look at this scenario. If we have a $50 pair of shoes and they're going to charge us 5% sales tax, well, that adds $2.50 to the original 50. So the total amount, by the way, if you ever see these three little symbols like that, these little dots, that means therefore. So therefore, the total cost is $52.50. That's what you have to pay for the shoes. Okay. So what increased here, or what was the increase, was the percent. So what is the original percent? Well, the original percent would be 100, and they increased it 5%. So you can consider then, it can be calculated directly as using the fact of that it's 100% originally. They increased it by 5%. So that is the same thing as increasing it by 105%. So another way to look at that is the increase. I'm going to write the verbiage out. So increase of the percent, instead of writing the word percent, implies a new amount. But I'm going to put the percent implies a new amount. I'm just abbreviating here. Or you could have the increase, okay, of the percent. So another way to look at this is you have the increase. I'll write this out too. Well, we decided the increase would be 100% plus whatever. I'm going to say, in this case, n percent. They use X in the book, but I'm using this because with the X's and the pluses, I think we get confused, of original amount. Well, in our particular case, the increase was 100% plus 5%, which is 105%. So an increase of the percent of, this of indicates multiplication. So I'm going to use a dot for my multiplication. The original amount. What was the original amount? The original amount was $50 for the shoes. So in this case then, I just need to take 105% times 50%. Okay? I could write times like this too. 105% times 50. Now in this case, it's always nicer to multiply than have a fraction and a ratio. And so you can multiply that out. And of course, you're going to end up getting 50 to 50. Whoops. Let's do that. I want to do that real quick. I'm just taking a moment here. I had walked away from my calculator. Trying to remember where I laid my calculator down. Don't get old. That's all I got to say. All right. My calculator doesn't do percents. So, yeah, you multiply that out. That was right. If you get percents, you're going to get 5250, so it gives you the exact amount. Okay. If you don't have a percent button, if you have a simple calculator, you'll end up getting 5,250, and you just got to remember to move your decimal to the left two places to get the percent. Right, now that's for the increase. The decrease works the same way. So what they've just said is they said if you have 100%, that's what that represents, whatever the total item is, plus whatever, I tell you what, let's just do whatever the percent increase is. Okay? And in this case, the opposite. If you're talking about decreasing, then you could take the 100%, and this is the increase percent, minus the decrease percent. Okay, so it's the same way. Your book plugs it in and says 100% plus X percent, or they have 100% minus X percent. All I'm doing is just using a different variable. But the decrease, so if I was talking about something decreased, then you would take the decrease of the original amount. So I'd take this times, like we did this one, the original amount, and we can find out what a decrease is. So let's look now at example 3, and I bet example 3 is talking about the change in percents, not a dollar amount and not in votes. So let's look at that when the change is in percents. It says population projected growth by, so they're projecting that the growth, the population growth, is going to go up 7%. Okay, growth implies up, right? When you grow up, you increase. The current population, so they're telling you what the current population is, which is 35,000. So that's the original, right? And they're wanting to know in 10 years, okay, how many people are in 10 years? Because they're saying this is a 10-year projection. Okay, in 10 years we project that the growth is going to increase by 7%. Okay, and the current population is this. So in 10 years is the question. Basically, how many people, or what's the population, right? Well, if we look at this as the old value here as 100%, they are increasing by 7%, and we can take that times, I'm going to use parentheses here, by 35,000. So we're taking the percent of the original value. Well, this would be 107% times 35,000. All right, you can multiply that out onto your calculator now. If you have a percent sign, you could say, you could put in 107% of 35,000 if you have one of those nice fancy calculators. If you don't, drop your percent, move your decimal over, and you get 1.07, and then take that times 35,000. If you have just the basic calculator, and you're going to get 37, it's hard to write at this angle, 37,450. The story problem, people in 10 years, or the population will be 37,450 people. All right. So we don't have to do that percent change and deal with ratios when the increase is, or the decrease is represented by percents. Let's look at example 4. Example 4. It says, talking about a runner. I need to turn my book, so give me a minute to turn my page. through dedicated training, a runner was able to decrease his time, because that's your goal. You want to run faster. So we're talking about decrease. So the runner, he decreased his time by 13%. To a time of 2 hours and 47 minutes. So now, does this time representing his new time, or does that time representing his old time? Ask yourself those kind of questions, okay? So this is his new time. I believe. Let me double check. I'm going to re-read the verbiage because I hand wrote it. To decrease his time in the marathon by 13% to a time of 2 hours per minute. What was his time previously? Right. Okay, so this is the new time, and they're asking basically what was his previous time. So you know it's going to be more, right? So when we're talking about the decrease here, we're going to consider this as 100%, and they're decreasing. He's decreasing it. So we're going to subtract times the original amount, right? The original time. Well, we don't know what the original time is. That's what we're trying to find out. So I'm going to say T for time, the original time. So he decreased that times the time. But they tell us what that answer is. They tell you, well, his new time was 2 hours and 47 minutes. Well, let's put this all in one unit. Let's put this all in minutes first. All right. So 2 hours converts to 120 minutes plus 47 minutes. Right? So we're going to add that up. That's going to give us 167 minutes. So now we're talking about the same units here. So now we have an equation that we can solve for the unknown. This is going to give me 100% minus 13% is 87% times whatever the new time is. Or not the new time, the old time. Okay? Well, drop your percent, make it a decimal. Remember, you're moving that to the left 2 places. Okay? And we're solving for t. They're multiplying here, so we're going to divide everything by 0.87. And this cancels out, and we get time is, and you divide that out, and you get 192 minutes. So he used to run at 192 minutes, but they wrote everything in the hours and minutes. So let's convert this to hours and minutes. So you're going to ask yourself, how many minutes in an hour? Right? There's 60 minutes in an hour. So you're going to take this 192 and you're going to divide it by 60. When you do that, you're going to get 3 point something. So that means you got the time was 3 hours. Well, what is 3 times 60? 3 times 60 minutes is 180 minutes. So take 192 minus 180. And you get 12. So there's 12 minutes left over. So you get 3 hours and 12 minutes. So this one, you kind of did a lot of things that you've been doing previously. You know, you had to know how to convert to percent to a decimal. You had to know how to convert it into 1 unit. That's what we've been doing before. Then you had to go back and convert it back. So his old time, the answer was 3 hours and 12 minutes. Wow. Think about that. Well, you think, oh wow, he's running an hour less, but he's really not, because this is almost an hour. So you could figure out what the change was, couldn't you? You could take this if you want. Let's figure it out. We're not asking you, but what if they said, what was the change? Well, the change was this time here, 3 hours, 12 minutes, minus the new 2 hours, 47 minutes. Now you're back to your basic math, right? You can't subtract 12 from 47, can you? So you're going to borrow from here. Well, here, I'll leave it. I'm going to borrow from here, leave that as 2 hours. I'm going to add 60 minutes because I'm borrowing an hour. This gives me 72 minutes, right? So now we have 72 minutes minus 47. Now you can subtract, right? And they're not asking you the change, but I just want you to realize that they could have asked you the change now that you had found out the other information. All right, so when you subtract that. So I would say for a runner, that's pretty good. He increased his time by 27 minutes. Or he increased his time, okay, by 27 minutes. Or by 13%. That's pretty big. Most runners, you may increase your time between 3 to 10 seconds. The next run and gradually, so it's usually more by seconds than minutes. So that's pretty good for a runner. That was example 4. Now what I'd like you to do for your practice is go to your practice exercise A, and I would like you to do problems 5 and 7. So you're going to pause the video and you're going to do for practice exercise A number 5 and 7, and then come back when you think you have the answer. So that's your practice. So 5, increase 700 by 40%. That's number 5. Oh, did I say 5 and 7? Let me make sure. Maybe it's 5 and 6. Nope, it's 7. All right, so 7. This one's a decrease. Decrease 600 by 55%. So hopefully for number 5, your answer was 980, and for number 7, your answer was 270. So let's work the problem. If you got the right answer, you don't need to continue watching, but unless you want to. So we increased by 40%. So of the 100%, we increased by 40%. And by, the word of and by, all those indicate multiplications, okay? So by 700. This gives me 140% of 700. And let's go ahead and we drop our percent. We're going to move our decimal over 2 places. So we get 1.4 times 700. And we're going to go ahead and move that into a calculator. And, or you could do it, I mean, you could actually do it on scratch paper. That one on scratch paper, you're going to need a calculator actually. However you prefer to do it. So you get 980. That's where your decimal is. I'm going to go ahead and write it to here. I just wanted to double check my work on that. Okay. So that increased, okay, by 40%. So it did increase, right? So what they're saying is your original amount was 700, and if you were to increase that by 40%, then your new amount is 980. Now, if it asks you for the change, you're going to take and subtract these two numbers, right? All right, number 7, it says decrease. All right, so we're decreasing 600 by, so we got 100%. We're decreasing by 55%. So we're going to subtract. By indicates multiplication. So that's what these two parentheses next to each other means. And 100 minus 55 gives us 45% times 600. Okay. Again, you can make that into a decimal by moving it over 2 places. So you get 0.45 times 600. And when you multiply that out, you get the 270. So that was pretty straightforward. Now this only works when you're talking about the percent change. Not the percent change, but your increase or decrease has to do with percents versus money, number of votes, number of books, those kind of things.